All right, so today we're going to get into types of reactions, types of chemical reactions. So when a chemical reaction takes place, there are 5 different categories that we put them into, and they kind of will all fall into one of these 5 categories. And if we know that it's a certain type of reaction, that will tell us a little bit about that particular reaction. And because they all kind of act similarly. So the first kind is a synthesis reaction. Synthesis means to make or to produce. It will also be called an addition reaction, but most of the time you'll see it as synthesis. And the general form is A plus B yields AB. So it's where two elements usually form one compound, or it could be 3 elements form one compound, but that is the general form. An example would be water, and then if I balance it, so that would be an example where you have hydrogen plus oxygen yielding water. Okay. The next one is a decomposition. It has the word decompose into it. It means to break down. So hopefully you can kind of guess that it's kind of the opposite of synthesis. So instead of two things forming one thing, it's one thing, one compound breaking apart into multiple products. So it would look something like this, decomposing. And so an example of this might be the opposite reaction that we have with water. Basically breaking water apart into something else. The next one is single replacement. A single replacement reaction is where one element plus a compound, and so the reactants look like this. So you have an element plus a compound, and this element takes the place of one of the other elements in the compound. So, and kind of kicks the other element out. So A, in this case, took the place of B in the reaction. So an example of this might be sodium plus magnesium chloride yielding sodium chloride plus magnesium. And then we got to balance that. Okay, so sodium took the place of the magnesium. Now the magnesium is by itself and the sodium is with the chloride. So single replacement, one thing is replacing one other thing. Then we have double replacement, which is where we have 2 compounds, so AB plus CD, and then on the other side everyone switches. Okay, so you have A going with D and C going with B. So with this, the outsides go together and the insides go together on the other side. So you'll have A with D, C with B. Okay. An example of this would be like an acid-base reaction. Hydrochloric acid plus sodium hydroxide yields water plus sodium chloride, NaCl. So notice H went with the OH to produce H2O, and then Na went with Cl to produce NaCl. One thing about these are always the longest because they have the most elements. So that's kind of a good way if you're trying to identify them. If it's really long, most likely it's going to be double replacement. The last one is combustion reaction, and combustion has to do with fire, burning things. So this is the most specific. This is always includes carbon, hydrogen, and oxygen. Because what you have is you always have a hydrocarbon, so CH, these could be any numbers down here, so it could be CH4, C2H6, plus O2, so when this is your fuel, and then you always need oxygen to burn anything, and then your products for combustion will always be CO2 plus H2O. So when you're trying to identify this, what you're always looking for is there a hydrocarbon, a carbon-hydrogen compound? Is there oxygen? And then are my products CO2 and H2O? Because those will always be there, present, if it's a combustion reaction. All right, I hope this helps. Let me know if you have any questions.